Hello students, my name is Sumit Mehta. Today we will cover in this video is what are the relation between zeros and coefficients of a polynomial. In my previous video on polynomials, I taught you about what are the polynomials of degree 1, degree 2 and degree 3 and what are the basic polynomials and what are the zeros of the polynomials. So in this video we will cover how to find zeros and what is the relation between the zeros and the coefficients of a polynomial. Let me write a quadratic polynomial first. Okay, ax square plus bx plus c equals 0. So what are the relation between zeros? Let me say, let's say x1 and x2 are two zeros or roots of quadratic polynomial. Basically, zeros are those values at which the polynomial gets the value of 0. So, at any value of x1, if the polynomial values become 0, so this is why it is called as zeros of polynomial or the roots of a polynomial. In my previous video, I also tell you about the graph of a pictorial representation of a quadratic polynomial will looks like this. Okay, it can be uh, this touching at one point, or it can be means no real root, two equal roots, two distinct roots. Okay, so what will be the condition for that? B square minus 4ac greater than 0, b square minus 4ac equals 0, and b square minus 4ac less than 0. Okay, so I hope you guys are clear now. So now I will tell you about the relation between zeros and the coefficient of a polynomial. So to find out the sum of the zeros of this polynomial, which means x1 plus x2, if which we assume as the two zeros of polynomial, this will be equal to negative coefficient of x upon coefficient of x square, which means minus b by a. So sum of zeros will be sum of zeros for a quadratic equation or quadratic polynomial will be minus b by a. So similarly you can write the product of zeros, means if two zeros are x1 and x2, the product of x1 and x2 will be constant term upon coefficient of x square, which is c by a. So these are two important relations which we define in present, and there will be lot of question directly asked to you, what are the sum of the roots of this polynomial and what are the product of the roots of this polynomial. So you can directly use this formula for some of the zeros or some of the roots of a quadratic polynomial. This is minus b by a and the product of root is c by a. I hope you guys are clear now. If you are still facing any issue, then please comment in the comment section. Let me give you some more example to clear this topic. So students, here is one example for you guys. Verify the zeros of the quadratic polynomial. So first we have to find out the zeros of the polynomial and verify the relation between the zeros and its coefficient. So first let me check out what are the zeros of the polynomial. So as I taught you in my previous video of quadratic equation, so you can directly split the middle number in such a way that the sum will be equal to this b and the product will be equal to c and a. Okay, so x square plus 5x plus 2x plus 10 equals 0. So you can directly write x plus 5 and x plus 2. I have skipped one step, I hope you can do now. X equal to minus 5 and x equals to minus 2 are the two zeros of this polynomial. So now we will find the relation between the zeros and the coefficient. So as I told you the formula that sum of zeros is minus coefficient of x upon coefficient of x square. So this will be equal to minus 7. Okay, minus 7 by 1 which is equals to minus 7. And so you can judge it from this, means if these are the two zeros, means so the sum of minus 5 plus minus 2, this will also equals to minus 7. So what we are getting here is, I think it is a correct. So this we have to verify whether the relation holds true or not. So this relation is holding true. I hope you guys are clear now, because the two roots which we are getting was minus 5 and minus 2. And after directly applying the formulas of sum of zeros, we are getting the same as our answer. Let me check again for product of zeros. Product of zeros will be constant term upon coefficient of x square, which is c by a. So c here is 10 upon 1, which is 10. So you can also cross check is the product of our two roots, which are minus 5 into minus 2. This will also equal to minus 10. So you can see from here that this relation always holds true, means the sum of the zeros by directly applying the formulas of minus b by a by comparing it to the standard quadratic equation, and after getting the values of a and b, you can directly apply the formula minus b by a for sum of the zeros. You will get the value as sum of zeros. Okay, and similarly for product of zeros, the formula is c by a, and the c and the a you will get it after comparing it this quadratic equation with the standard quadratic equation. Guys, let me give you one more example on cubic polynomial and how to find the relation between the zeros and coefficients of cubic polynomial. So students, here is one example for cubic polynomial, and I'll tell you about the relation between the zeros and the coefficient of the polynomial. And the three zeros of this polynomial are x1, x2 and x3. So basically I will tell you about what is the relation between the zeros and the coefficient of the polynomial. So let me write first the simple formula as we wrote in for a quadratic equation. Okay, so the sum of the zeros or sum of the roots means x1 plus x2 plus x3 will be equals to negative coefficient of x square upon coefficient of x cube, which means minus b by a. This formula is looking similarly like the sum of the roots in quadratic equation, but you guys should be very careful before applying the formula, because here these are the constant terms of a cubic polynomial, and if you are directly applying a formula, you first need to compare any cubic polynomial. Like if you are getting this polynomial in exam, so first you have to compare this cubic polynomial with the standard cubic polynomial which we assume. Okay, So the sum of the roots taking two roots at a time, x1, x2, x2, x3, x3, x1 will be equals to coefficient of x upon coefficient of x cube, which is equals to c by a, because coefficient of x is c and x cube is a. So this is another important relation you need to learn, because in exam you will directly come face simple questions directly on these formulas. So you need to learn these formulas by your heart. Okay, there is one more formula regarding the product of zeros or roots, means x1, x2 and x3 will be equal to constant term, negative of constant term upon coefficient of x cube, means minus d by a. So guys, I'll tell you the shortcut about how to learn these formulas. See the basic structure. First I have write in the numerator of the sum of the zeros, which is minus b by a. First there is a negative sign, then there is a positive sign, and then there is again a negative sign. So there are three formulas of a cubic polynomial in which alternate sign changes, and in the denominator there is always a. Okay, so you can see here that you are getting a always in the denominator, and the value in the numerator changes from b, then c in second formula, then d in third formula. So the first formula goes like the sum of all the roots is minus b by a. Sum of the roots taken two roots as at a time is c by a, and product of the roots is minus d by a. Alternate positive negative, and in the denominator you will always get a, and the numerator you will get b c d one by one. Okay, I hope you guys are clear now. Let me give you one example to directly find out the relation between these two roots. Okay, so student, here is an example of a cubic polynomial where it is given that verify that these three are the zeros of a polynomial. How you will verify these, whether these three are zeros of polynomial? By putting the value of 3 minus 1 or minus 1 by 3 in this polynomial. If this polynomial gets 0, so these are the zeros of this polynomial, and then you have to verify again the relation between the zeros and the coefficients. So let me do for 1 0. I am verifying that whether minus 1 is a zero of this polynomial or not. And you need to do yourself whether 3 and 1 by minus 1 by 3 are zeros of this polynomial at your home. Okay, so this 3 minus 1 cube, I am putting the value of minus 1 in the cubical equation. Okay, so what I am getting is minus 3 minus 5 plus 11 minus 3. So all the minus 11 plus 11 becomes 0. So this is a 0 of this polynomial. So it is pretty clear now that this one is definitely a 0 of this polynomial, and you need to work on 3 and minus 3. You need to check whether 3 and minus 3 are also the zeros of this polynomial. So I am assuming for now that these are also the zeros of this polynomial. You will do this at your home or yourself. Okay, so I am doing the second step of this question, verifying the relationship between the zeros and the coefficients. So the sum of zeros, as I told you the formula by directly applying the equation, which was h cube plus bh cube plus ch plus d. I am comparing this equation with this equation, so I am getting the sum of zeros was minus b by a, and b here is minus 5. and a is 3. So this is 5 by 3. So let me check whether this 3 gives us 5 by 3. 3 minus 1 minus 1 by 3. So let me take the LCM of all the 3. 9 minus 3 minus 1, which is 5 by 3. So I have just cross verified that the sum of all the 3 roots given to us is equal to the sum of the zeros from which we are getting directly from the formula. So you can now apply the formula of sum of zeros taken two at a time and product of the zeros by yourself. If you still face any issue, you can comment in the comment section. I hope you guys are pretty clear about the cubic polynomial and quadratic polynomial. If you still face any issue, please do write to me. Thank you, students. Thank you all.